right, today we are starting 3 variable systems, which really aren't too much different than 2 variable systems. So a 2 point would determine a line as in a 2 variable system. A 3 point system determines a plane. So when we're talking about a system with 3 variables, we're looking at where do the planes intersect, and your answer is going to be an ordered triple with x, y, and z. So the first way we are going to talk about this today is with substitution. Just like with the 2 variable system, you can solve with substitution and elimination. We're going to start out with substitution, which is where we're going to choose one variable to isolate in one of our equations. We will substitute it into the other 2 equations to get down to a 2 variable system. And then from there, you're going to solve your 2 variable system and use back substitution to find x, y, and z. So in a 3 variable system, I have 3 equations. I'm going to number them 1, 2, and 3 so that it's easier to identify what we're referring to. So I'm going to look at my 3 equations and I'm going to decide, out of those 3 equations, is there one of them where one of my variables is going to be the easiest to isolate? Meaning, I hopefully don't want to divide because I don't want to deal with fractions. And if I'm looking around, it looks like in equation 2, I can get x by itself without dividing. So what I'm going to do is rearrange this equation for x by subtracting 3x and adding 3z. So x will be negative 3y plus 3z plus 3. Now that I have x alone, I'm going to substitute that into equation 1 and equation 3. So starting with equation 1, that's going to be negative 3, and then in parentheses, negative 3y plus 3z plus 3 plus y minus 3z equals negative 9. Parentheses are important because I'm going to be distributing this negative 3. And once I have done that, I am going to combine like terms. 9y and y gives me 10y. Negative 9z minus 3z gives me negative 12z. And I'm going to add my constant to the other side. So this equation is equal to 0. I now have a new equation with only 2 variables, and I'm going to call it equation A. Okay, so that was plugging x into equation 1. Now I need to do the same thing into equation 3. So 7, negative 3y plus 3z plus 3 in parentheses, minus 2y plus 3z equals 3. Again, I need to distribute. And then I'm going to combine my like terms, negative 21y plus 24z. Again, I'm going to get all my constants on the same side, and this will be equal to negative 18. I have a second new equation with only 2 variables, and I'm going to call it B. Now that I'm down to 2 equations with 2 variables, I can decide, do I want to continue with substitution or will elimination make my life easier? Well, here I'm going to get fractions if I try to do substitution. So I'm going to eliminate, and I want to eliminate my z's because I've got 24z here and negative 12z here. So if I multiply equation A by 2, then I will get 20y minus 24z equals negative 18. And I realized I have a little boo-boo here. This is not negative 21y. This is 23. Negative 21y minus 2y. Okay, so those cancel. Negative 3y equals, and again, still don't know where my head's at. 0 times 2 is 0. Okay, negative 3y equals negative 18. So y is equal to 6. Now that I know y is 6, the next variable I can solve for is z. I can find that by plugging into A, B, or this equation we multiplied. I'm going to go with equation A just because these numbers look a little easier to work with, look a little smaller. So 60 is equal to 12z, which means z is 5. Now that I know y and z, I need to find x, and I can do that by plugging y and z into any of these equations. Again, it's just up to you. Whatever you think is easiest. I'm going to go with this one where x equals. So x is going to be equal to negative 3 times 6 plus 3 times 5 plus 3. Negative 18 plus 15 plus 3 is 0. So my ordered triple is 0, 6, 5. Okay, let's do another example. Again, I've got 3 equations. And as I'm looking, I am picking out that equation 2. If I get y by itself, that's going to be the easiest for me to work with. So I'm going to rearrange this into y equals negative 5x minus 3z plus 6. And I'm going to substitute it into equation 1 first for y. So 2x minus 2 times negative 5x minus 3z plus 6 plus 3z equals negative 9. So plus 10x plus 6z minus 12. I'm going to combine my like terms. 12x plus 9z equals 3 will be equation A. Now I'm going to plug y into equation 3. Negative 7x plus 5 times negative 5x minus 3z plus 6 minus 3z equals negative 8. Again, I have to distribute. So on this one, I'm going to get negative 32x minus 18z equals negative 38. So between A and B, again, I'm going to choose to do elimination now. My 9z and my negative 18z are going to cancel quickly if I multiply this one by 2. So I'll get 24x plus 18z equals 6. Negative 8x equals negative 32, which means x is 4. Then I can find z. I'm just going to plug into equation A. So 9z is going to equal negative 45, which means z is negative 5. And then to find y, I'm going to use this equation we solved out. So negative 5 times 4 minus 3 times negative 5 plus 6. Negative 20 plus 15 plus 6 is going to give me a total of 1. So my ordered triple here is 4, 1, negative 5. All right, on to some special cases. On example 3, again, I've got 3 equations. I'm going to do substitution. I'm going to get equation 1 by solving for z. And I'm going to plug that in first to equation 2. 2x minus 6y minus negative x minus 2 equals 19. So distributing that, this is going to become plus and plus. So I'm going to get 3x minus 6y equals 17 for my equation A. Then on the next one, 4y plus 2 times negative x minus 2 equals negative 6. I have to distribute. And I get negative 2x plus 4y equals negative 2 for equation B. Looking here between A and B, they're both going to be kind of equally as difficult to cancel for elimination. So I'm going to look at my x's, 3x and negative 2x. They have a common multiple of 6. So I'm going to multiply equation B by 3. Negative 6x plus 12y equals negative 6. Then I'm going to multiply equation A by 2 and get 6x minus 12y equals 34. And when I combine these, I get that 0 equals 28, which is false, so this is going to be no solution. Okay, I am running out of time, so I am going to do example 4 in a separate video.